So if I look at the next set of problems, it says which of the sequences converge 31 through 100 and which diverge. Find the limit for those sequences that do converge. So if I actually start with the first number, I'm going to take number 34, the limit as n approaches infinity of 2n plus 1 over 1 minus 3 radical n. I could use L'Hopital on that, of course, if I wish, or it'll be a lot more efficient if I divide it by the highest power term of the denominator. That's still a very nice trick. If you divide n by radical n, that's twice radical n plus 1 over radical n. So this will approach 0. This will approach 0. I'm looking at infinity plus 0 over 0 minus 3, which is infinity. Therefore, diverge. Done. So that's basically it. That's a conclusion. Here, I'll take the limit as n approaches infinity. Again, I could use L'Hopital, or I could say I'm going to divide by the highest power term of the denominator. That's going to save me a lot of work. So that will approach 0, that will approach 0. You're left with n over 4, and you're taking the limit as n approaches infinity, and that will approach infinity, therefore diverge. All right. And on the next one, now you gotta be careful with the alternating part. So my advice, ignore the alternating part and take the limit. If you get any number, that means as n approaches infinity, the limit doesn't exist because of oscillation. If you get 5, that's going to be 5, negative 5, 5, negative 5. So unless you get a 0, any number other than 0, and the reason for that, if you say plus or minus 0, that's the only number that plus or minus is identical. So I'll ignore this. I'll take the limit as n approaches infinity of 1 minus 1 to the n. As n approaches infinity, that's going to be a 1. So I know, this is the side note, right? Here, I do know that here, this limit as n approaches infinity of this a sub n is going to be 1 or negative 1, depending whether n is even or odd, which means does not exist. Therefore, diverge. So, if the limit exists as a number, it converges. Otherwise, what's otherwise? If you get infinity or doesn't exist, that's not a number. Therefore, it will diverge. Next set of problems. Limit as n approaches infinity. Remember, this is 1 over an exponential. This is exponential decay, right? As n approaches infinity, this will approach 0, and 1 over 0 is infinity. Therefore, diverge. This is a bit messy, just a bit. Cosine n pi. N equal 1, I'll get a negative 1. N equal 2, cosine of 2 pi is 1. 3 pi, 1. So a sub n actually is negative 1 to the n times n pi. And if I take the limit as n approaches infinity of n pi, that will equal infinity, right? In reality, if I take the limit as n approaches infinity of a sub n, that will be plus or minus infinity, which means does not exist. Either way, we say it's divergent. This problem. Well, I know the top is bound between 1 and -1. That's actually 0 and 1. The denominator is growing without bound. That limit is going to be infinity. 0. How do you show it? Well, you're going to say the sine squared of n over 2 to the n. The smallest that could ever be is a 0 because it's positive, right, over 2 to the n, which is 0. And the biggest that could ever be is a 1. And if I take the limit as n approaches infinity of 0, that's 0. The limit as n approaches infinity of 1 over 2 to the n is 0. Therefore, limit as n approaches infinity of the sine squared of n over 2 to the n equals 0 by sandwich theorem or squeeze theorem, therefore converge. So all of these diverge except for this one. Now, majority of those do turn out to be convergent on the long run, but for now it doesn't really matter. So I don't want you to make one call or another. Oh, you know, there are more convergent than divergent. That's not true. We really don't know. All right, and another set of problems, and we're done. This problem, 62. If I take the limit as n approaches infinity of n plus 4 raised to the 1 over n plus 4, well, that's infinity to the 0. We have a problem. That's the limit as n approaches infinity. And what did we say we do? E to the natural log of n plus 4 to the 1 over n plus 4. That would be the limit. That would be e to the limit as n approaches infinity. And as we played with this back in the days, we're going to move this up front. And it benefits me to write it like this better. By now, hopefully, you're comfortable with that. That makes it infinity over infinity. So I apply L'Hopital, limit as n approaches infinity. The root of the top is 1 over n plus 4, bottom. So that is the limit as n approaches infinity, e to the limit as n approaches infinity of 1 over n plus 4. Isn't that 0? And that will be e to the 0, which is 1. Therefore, it converges. So you have to show me that. Every time we come across that, that's section 4.5. We have plenty of those. And how about 66? The limit as n approaches infinity. I'm going to write that as a power, rational power. And don't you multiply those? Isn't that 2n plus 1 over n, or simply and there it is. Flying by those. Well, we did those in section 4.5. If you didn't do that with us, go back and do it again. Now, factorial, something to always look for. A trick I'm going to show you, not that we need it after 10.6. You could use that, but this is a very good trick to use all throughout. If I told you we're dealing with 5 factorial over 3 factorial, do we see that the top is 5 times 4 times 3 times 2 times 1? Since it's always multiplication, do you see if I take the bigger factorial and start reducing it, eventually I'll get to the denominator? Meaning, if I had 99 factorial divided by 97 factorial, no need for me to write all 99 terms. I could start with 99, the bigger, 98, and stop there, because this is all multiplication. And those will cancel out, and I'm left with 99 times 98. That's a trick you should really get down. when I'm looking at this problem, I notice that n plus 3 is bigger than n plus 1. So what I'll do, I'll leave the top alone. I would say a sub n is actually n plus 1 factorial, and I'll start reducing the bottom. N plus 3 minus 1, n plus 2 didn't match. Minus 1, and I am aware I'm going to get to the top, and those cancel out. So that's really what this is. This is 1 over n plus 3 into n plus 2. And if I take the limit as n approaches infinity of 1 over n plus 3 times n plus 2, I know that's a 0, therefore this converge. And there is my homework. One through 17 odd, 31 through 73 every other odd, and number